Right-hand rules. In this video, we'll be looking at the magnetic field that's created when charged particles move. When current flows through a wire, a magnetic field is created around it. So in physics, when we talk about current, it's just moving charged particles. You can see in this diagram on the right-hand side, we've got two permanent magnets with a magnetic field shown with the arrows. Then the wire is going in and out of the page in between the two permanent magnets. When the wire has the current running through it, creates a magnetic field and distorts the magnetic field produced by the permanent magnets. Now in this area, the magnetic field is represented by field lines, where the spacing between the field lines represents the magnitude of the field and the arrows represent the direction. And what we can see from this is that when the magnetic field lines combine, a force is created on that wire, and in this case pushes the wire to the right hand side. In previous video, we were looking at the magnetic field in three different situations, being the wire, the coil, and the solenoid. And the right-hand rules were as follows. In all these cases, the best way to remember how the field lines are produced is to grab the object in question naturally. So with a wire, you'd grab it as shown in the diagram on this left-hand side. Your thumb points in the direction of the current, and your fingers point in the direction of the magnetic field. With a coil, you grab it like a hoop, and your thumb points in the direction of the current, and your fingers in the direction of the field. So it's the same as the wire, just curled around. And the final case is the solenoid. So in this case, you can do it just by grabbing the wire like with the coil, but with multiple coils, we'd grab the solenoid as shown in the diagram. Your fingers this time point in the direction of the current, and your thumb points in the direction of the field lines and towards north. Now we'll look at the force that's produced when a wire with a current is already in the magnetic field, and the combination of the two magnetic fields produces a force on the wire. So we're going to use what they call the right-hand palm rule. Your fingers point in the direction of the magnetic field, your thumb points in the direction of the conventional current in the wire, and the palm points in the direction of the force that is on the wire. So let's look at an example. So start with pointing your thumb in the direction of the conventional current in this wire. So you can see it's going up. So thumb will go up. Your fingers will be pointing to the right. So when you're looking at this, your fingers will be pointing at your right, and your palm will be facing the screen. Okay, and what that means is that because your palm's facing the screen, that's the direction of the force on the wire. In a situation where the wire is parallel to the magnetic field, the current is going in that parallel direction, we can't apply our right-hand rule. It just doesn't work. And in this case, the force on the wire is zero. So by observing this, we find that the maximum force on a wire is when that wire with the current running through it is perpendicular to the magnetic field, is zero when it's parallel to the magnetic field, and is an intermediate value when it's in between. So observing the wire in this magnetic field, determine what will happen to the wire. The best way to do this is to break this wire up into different sections and determine the force on it at those different sections based on the direction of the current.